Obviously, this here is a double displacement reaction. Now, the question here is how did we come up with this particular conclusion? First off is that we need to identify what is going on here in this reaction. We have compounds noticed here in the reactants, and we have compounds noticed here as our product. This particular compound here, which is known as sodium ethanoate, going to form ions present. That is one. We have our ethanoate, and we have the particular negative charge that is present there, and our sodium is always what, cation. And so this here in the reactant part shows also the other reactant, which is called the perchloric acid, and this here can be split into two ions. The first ion is hydrogen or a proton ion, and the other one is a perchlorate ion. Take note that it is a negatively charged species. Now what is going on is that we notice that there is going to be the switching of partners, that is in this case opposites, new opposites attracting, which means we have a negative and positive, new positive interact with each other, and we have the other positive and negative interacting with each other. Therefore, we are able to form our product here, which is in this case known as ethanoic acid. How this here is drawn structurally speaking, this here has three hydrogens bonding to the first carbon, and the other carbon here has an oxygen double bond with a hydrogen bonding to the other oxygen, and that oxygen bonds to the other carbon. And so this here is our first product, and while the other formation here that is formed right here is going to be what, our sodium ion forming interaction with the perchlorate. And perchlorate, when you look at the structure speaking, it has a Cl with almost like double bonds around the oxygen, but on one side we have a negative charge present in here that makes this to be the anion. Some groups they actually have the brackets because this here kind of forms resonance structures, in the sense that you have new double bonds forming. So this here is a little bit more accurate with regards to the result that is formed right here. So overall, I hope you found this really informative as to how this particular reaction is a double displacement reaction.